In this episode, we're going to look at how to investigate a VLAN implementation. I'll show you how to do it, and we'll talk about the concepts along the way. We'll observe how broadcast traffic is forwarded by switches when VLANs are configured and when VLANs are not. Greetings to all my tech heads out there in the KevTechify Nation, and if you're new here, welcome. This episode is part of my series on configuration examples for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Investigate a VLAN implementation. Here I have the packet tracer lab open. On the left side, I have the main window where we have our topology, where we'll interact with all of our devices. On the right side, I have our instructions. The bottom right is the standard packet tracer activity window that opens up when you open up your packet tracer file. And then the upper right, I have the Word document of those instructions. Now, I use the Word document because there's several questions we have to go through and answer in this lab. The Word document allows me to save my answers. So I fill in my answers in that Word document. Here's our topology. We have 3 switches as the core. Each one of those switches have 3 PCs connected to them. Each one of those PCs is in a different VLAN, VLAN 10, VLAN 20, VLAN 30. That gives us 3 PCs in each VLAN. So PC1, PC7, and PC4 are all in VLAN 10. Here's our addressing information. We have our IP addresses, subnet masks, default gateways. The objectives of this lab is to observe broadcast traffic with the VLAN and then observe that traffic again without the VLAN and see how all of this information travels across our network. Part 1, observe broadcast traffic in a VLAN implementation. We're going to ping from PC1 to PC6. First step here, 1A, wait for all the green lights to turn green. I started this up a couple minutes ago. All these connections here are green. If you have red, restart your lab. If you have an amber circle, then just wait a minute or two, or you can click this fast forward button down here and it advances time by about 30 seconds when you click it. All of these should turn green like I have on my screen here. Click the simulation tab and add a simple PDU. Click PC1, then PC6. Down here in the bottom right of the main packet tracer window, it says real-time and simulation. It's about the middle bottom of my screen. What we need to do is click on simulation. I'm going to go ahead and do that. Opens up our simulation pane. Then we have to add a simple PDU, simple protocol data unit. That is this envelope, that the one that is sealed. If you pause there above it, it says add simple PDU when you mouse over it. I'm going to go ahead and click on that. When I move my mouse to the work area, my pointer turns into an envelope with a plus sign. That's what we wanted. And then we are going to send that PDU. This is a simple one. So you just click on where you're going to start, PC1, and then we're going to send it to PC6. PC6 is down in the bottom center. Go ahead and do that. And then we can see they've added in a couple PDUs for us. We have a green PDU and a blue PDU on my screen. Your colors are going to be different, but each envelope identifies a different PDU. First, we did the ICMP. That's the ping. Basically, what we're doing is pinging from PC1 to PC6. But before we can do that, ping uses a layer 3 IP address. Before we can do that, we have to get the layer 2 address of PC6 because it's on our local network. We send it to the MAC address. In order to convert that IP address into a MAC address, we use the Address Resolution Protocol, or ARP. And that's what the second PDU is. It happens to be my green here. Step 1C, click the capture forward button to step through the process. Observe the ARP requests as they traverse the network. When the buffer full window appears, click the view previous events button or stop when the ICMP ping completes or fails. Down here in my window on the bottom, I have this special little window open. If you don't have that, you have this gray vertical line right here. This gray vertical line has a dark gray triangle that points to the left on it. If you click anywhere on this gray vertical line, it opens up this window, and we can see that we have one PDU here. The source is PC1, destination is PC6, and it's in progress. And now this is what we're waiting for up here in step C. When the buffer full window appears, there'll be a pop-up in the middle of the screen, or when the ICMP completes or fails. Instead of saying in progress down here in this window, it's going to either say complete or fail at that point in time. Once we do that, we can stop clicking the capture forward button. The capture forward button is down here. If you look underneath PC3, you drop straight down on my screen. It's this button here that has a triangle that points to the right to the line. If you pause over it for a second, okay, if you pause over it for a second, it's going to say capture, then forward. What I had to do was click in the window to make it the active window. And then once I did that, I paused over it. This is the capture forward button. And what we're going to do is go ahead and click on that until we either get the window that pops up that says buffer fail or complete or failure down here in the status. Go ahead and click forward once. The ARP request goes from PC1 down to switch 2. Switch 2 gets it in, and then switch 2 sends it out to every device, every port on our local area network. Remember, we're dealing with virtual LANs here. We're only going to send it out virtual LANs and trunk connections. There is only one PC, one port on VLAN 10. We did not send it out down to PC2 because that's on a different VLAN, VLAN 20. We didn't send it to PC3, that's on VLAN 30, but this is a trunk connection between the switches. Switch 2 only forwarded it to switch 1, it didn't forward it to the other PCs. Switch 1 receives it in. I'm going to click the capture and forward button again, and it forwards out all the ports that are on the same VLAN. It can look at the packet, it can see the header, see it as VLAN 10, so we've forwarded out port 11 here to PC7. PC7 gets it and says, nope, that's not my IP address. I'm just going to delete the frame. The other PCs, the other ports, not on VLAN 10. We're not going to forward it out there, but we will forward out the trunk that goes between S1 and S3. S3 gets it in. I'm going to click capture then forward, and it forwards it out any port that is connected to VLAN 10, and that's PC4 here. I click capture forward again, ARP. Now all of a sudden, if we look down here for our PDU, it says it failed. The ICMP failed because we could not get to PC6. Were the pings successful? No, they definitely were not successful. Now we need to explain why. The pings were not successful because PC1 is on a different VLAN than PC6, which won't allow these devices to communicate with each other because they are separated logically. Once again, these are separated logically. They're virtual switches. They're done in software. It has nothing to do with the ports on the front. We group these ports logically, physically in software to create these VLANs. And once again, because PC1 is in VLAN 10, PC6 is in VLAN 30, they can't communicate with each other. They're separate networks. Do a little corrections here. Always good to get your spelling. Communicate. VLAN. Look at the simulation panel. Where did S3 send the packet after receiving it? After S3 got it, and what I'm looking at is the simulation panel here. The last device looking down this column was S3. S3 sent it to PC4. Now, why did it send it there? Because PC1 and PC4 are in the same VLAN. Because they were in the same VLAN. S3 sent it to PC4 because it was on the same VLAN. Okay. In normal operations, here we go. When a switch receives that broadcast in, that frame on one of the ports, it forwards it out all other ports when we don't have any VLANs. But when we have VLANs, we only send it out the ports that are on the same VLANs. Keep in mind that the switch does not send it out the port it received it in on. As we look here, switch 2 sends the ARP request out F0 to switch 1. That's a trunk. We'll send it down that trunk there, and we won't send it to anything else at that point in time. When switch 1 gets it in, we send it out port 11 to PC7 because they're on VLAN 10. That's the originating VLAN, and we'll send it out the trunk connection. Then when switch 3 gets it in, we send it out port 11 here again. That's because it's associated with VLAN 10. It never makes it to PC6 because that's a different VLAN. Step 2, ping PC1 to PC4. Click the new button under the Scenario 0 drop-down tab. We're looking down here, bottom center of my screen. Right here it says Scenario 0. We want to click on the new button. It now creates a Scenario 1. We have two scenarios, Scenario 0, Scenario 1. Add a simple PDU to ping from PC1 to PC4. The simple PDU here, once again, is that sealed envelope. Pause over, it says add simple PDU, and we're going to send it from PC1 to PC4. Go ahead and just click on PC1, and then come over here to PC4, click on it there. We add the two PDUs in there. We have the ICMP, that's our ping. Because we have to translate that to a layer 2 MAC address, we also do the address resolution protocol. Now I'm going to go ahead and click the capture forward button until either the buffer full window appears or ICMP pings or until the ICMP either completes or fails. Down here once again is our capture forward button. I'm going to go ahead and click on that. The ARP request goes to switch 2. There's no other VLANs associated with our original VLAN, VLAN 10. We're just going to forward it out the trunk. Click on capture forward. Capture forward then says, okay, any VLANs for VLAN 10? Yep, it's going to forward it out to PC7, and we'll forward it out the other trunk. You can see that PC7 says, nope, not my MAC address, so I'm going to delete it. Switch 3 gets that frame in, sends it out all ports that are in VLAN 10. That would be our PC4. PC4 gets that in. That's the ARP request. They make an ARP reply, send that ARP reply back to switch 2. Switch 2 gets that, sends it back to switch 1. Switch 1 sends it to switch 2. And notice we didn't have to send it to PC7 because PC1 was the one who did the original ARP request. PC4 knew exactly what MAC address to put in there for the destination, knew where it was located, and we can send it out. It's not a broadcast at this point in time. If you click the capture forward button one more time, it gets the ARP reply in. We can see the green check mark going, and now we can build that ping, that packet, with the correct MAC address here to get to PC4. And we don't have to broadcast it out any other pass. I'm going to click it once, goes to switch 2. Click it again, goes across the trunk port to switch 1. Click it another time, switch 1 to switch 3 across the trunk. And finally, we can send it out port 11 to PC4. They get in the echo request. PC4 then looks at that, makes the echo reply. Click forward again. The reply goes to switch 3, then to switch 1, switch 2, and finally It goes to PC1 on VLAN 10, and it successfully completes. And that's what we're looking for, successfully completing. Were the pings successful? Yes, they were. Now, why were they successful? Well, it has to do because they were on both the same VLANs. Because PC1 and PC4 both belong to VLAN, VLAN 10. So the path of the ARP request is the same as before, because PC4 is the destination. It replies to the ARP request. PC1 is then able to send the ping with the destination MAC address for PC4. Takes care of step 2B. Step 2C. Examine the simulation panel. When the packet reached S1, why did it also forward the packet to S3? Looking through here, when it reached S1, we're looking at the last device column, why did it send it to S3 and PC7? Well, that has to do with PC7 is in the same VLAN as 10. And our answer here is because PC7 also belongs to VLAN 10, and the ARP request was for VLAN 10, switches will forward to any device that are connected to VLAN 10 in their port. I hope you're liking this episode on practical configuration examples. Leave a comment on what you think about these configuration examples. If you still have a question or comment, please let me know below. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. Takes care of part 1. On to part 2. Observe broadcast traffic without the VLANs. Part 1, we had the VLANs. Now, part 2, we're going to clear the configurations. We're going to remove those VLANs. Clear the configurations on all 3 switches and delete the VLAN database. Return to real-time mode. That down here next to simulation, go ahead and click on real-time. Our simulation panel disappears. Delete the startup configuration on all 3 switches. What command is used to delete the startup configuration on the switches? That command, we're actually erasing a file from our memory. This is done in privilege exec mode. And I like to put what prompt I'm in. And so I'll put the name of the switch and I'll just leave it generic as switch. Then you put the pound sign, or my favorite, the waffle sign. And then the command here is we're going to erase, and then that file is called startup-config. Startup-config. And then we enter that command in on all 3 switches. Let's go ahead and do that. Switch 1. Enter in our CLI, enable, erase, startup-config. It's going to ask, erasing the NVRAM file system will remove all configuration files. Do you want to continue? Are you sure? And if you are, all you have to do is hit enter at that point in time to confirm it. And it will give you a message saying erase of NVRAM complete. I'm going to go ahead and minimize S1, click on S2. We're going to erase that file right away. I make that window a little bit bigger right and left. Oops, sorry, I clicked on the wrong tab. We want to go on the CLI tab. Hit enter a couple times, get into privilege exec mode by typing enable. And then our command is erase space startup dash config. Are you sure you want to remove it? Yes, I am. All I'm doing is hitting enter, and we have deleted it. Minimize switch 2, and let's connect into switch 3. Make it a little bit wider, right and left. Click on CLI. Get into our device. Get into privilege exec mode by typing enable, and our command is erase space startup dash config. Are you sure? Yes, I am. Just hit enter. There we go. Where is the VLAN file stored in the switches? The VLAN file is stored in a file called VLAN.dat. Now there's a couple memory locations inside of your switch. This particular file is stored in the flash. And this is like a thumb drive you plug into your computer where you can unplug it, it loses power. It doesn't lose what's on that thumb drive. It doesn't lose what's on flash. That's why we put all the VLAN data in that file. Because when we reboot the switch, we want that information to be there. And so we put it in flash. Where is the VLAN file stored on the switches? It is stored in flash. Typically, it's written as flash : to identify which memory system it is. And then our file name is VLAN.dat. Delete the VLAN file on all 3 switches. What command deletes that file stored on the switches? Once again, this is our file name. To delete it, we once again need to be in privilege exec mode. And so I'll put the prompt down there just to remind me what it is. And then it's delete, and then the name of the file. You could put the location followed by VLAN.dat. You could put that in there. But if you don't put the location there, it's going to default to flash. And most people, they just put delete VLAN.dat down, and that's good. I'm going to go ahead and minimize switch 3, get into switch 1 again. And privilege exec mode, that's right where we left it. Delete VLAN.dat. Oh, before I do that, I'm going to do something else. Here I'm going to type in dir to give us a directory listing of the flash. In our flash, we have the first file is our system iOS. The second is that VLAN.dat file. That's all the information about our VLAN file. We have that in there. Now I'm going to go ahead and delete VLAN.dat. It's going to say, is this the name you want to delete? VLAN.dat. If it is, just all you have to do is hit enter. Now, this is a confirmation. Are you sure you want to delete this one? And if you're sure, all you have to do is hit enter. All I'm going to do is just press enter, and it deletes it. I'm going to go ahead and type dir to get a directory listing again. And this time we only have one file in here. It is our iOS image file. We don't have any VLAN.dat. If we look back up here, it was a second file. It said VLAN.dat. It is definitely missing now that we have deleted it. We have successfully deleted it. I'm going to minimize switch 1 right here. Go to switch 2. Delete our VLAN.dat. Once again, you want the file name? Yep, hit enter. Are you sure you want to delete it? Go ahead and hit enter again. Minimize switch 2. And on to switch 3. We are still in privilege exec mode. Delete VLAN.dat. Is this the name of the file? If it is, go ahead and hit enter. That's all I'm doing is pressing enter. And then, are you sure you want to delete it? Yes, you are. Yes, I am. All I'm doing is hitting enter. It has now deleted it. Reload the switches. Use the reload command in privilege exec mode to reset all the switches. Wait for all the lights to turn green. To accelerate this process, click the fast forward time button. I'm going to go into switch 1 here. The command to reload it is just simply reload. You hit enter, and it says, do you want to continue with it? Yes, I do. I'm going to go ahead and hit enter. And you can see that it is reloading. We're loading in flash at that point in time. I'm going to go ahead and minimize it. Let's do switch 2. Reload. Are you sure you want to reload it? Yep. There we go. Minimize it. And notice all the connections around switch 2, that's the one I just reloaded, they turned red because the device is reloading. It's rebooting at this point in time. Once it comes up, then the switch has to go through auto negotiation of those ports. And that's what these orange amber lights are showing us. The round orange amber lights is showing that it's going through negotiation. I'm going to go to switch 3 here. Type in reload. Hit enter. Confirm it. Yes. It goes through the reload process again. Now, to speed this up, this is where you can click on the fast forward time button. Right down here, next to the clock, next to the time, it's 2 triangles pointing to the right. I can go ahead and click fast forward. Once, twice, 3 times. Now, this sometimes is a bug with Packet Tracer. For some reason, because I probably took too long typing in reload on all 3 devices, all 3 devices need to basically reload, reboot at the same time. Because I took some time explaining it to you, they successfully booted up before the other one started rebooting. And what we basically need to do is just cycle the power. Now, where we clicked on this button here for fast forward time, the button next to it is the power cycle button. It's like a circle with an arrow pointing on part of the circle. If you just cycle power on that, go ahead and click on it. Are you sure you want to do that? Yes, I am. Notice how all the devices go down at once, and they're going to come up here shortly. And you can click the fast forward time to make it go a little bit faster. Click it faster one more time, and now we have all green. This is where we want to go. Select scenario 0. That's down here in this window. If this window is not here for you, simply click on this gray line right here. It'll expand it out, and we want scenario 0. And once again, that was pinging from PC1 to PC6. When we had VLANs, they were in different VLANs, VLAN 10 to VLAN 30. But now we deleted all our VLANs, erased our startup config. It's all one flat network. Select scenario 0. That's what we did. From the simulation mode, click the capture forward button to step through the process. Notice the switches now forward ARP request out all ports, not just the ports that belong to the VLAN, because we erased those VLANs. It's going to forward it out all the ports. And this is where switches and VLANs help improve performance. When the buffer full window appears, click View Previous Events button or stop when the ICMP ping completes or fails. We can keep track of that ping and fail down here. Now I'm going to go ahead and click on the simulation button. Pulls it up here. It shows we have the 2 PDUs, one for the ICMP, the ping. The other one we have to do is the ARP request beforehand. And it says in the bottom window here, it says our PDU is in progress. I'm going to go ahead and click the capture forward button. PC1 sends it to switch 2. Then switch 2 is because we don't have VLANs. Remember, we deleted all the VLANs and erased all our startup config, rebooted our devices. It's going to forward it out. It forwards it out to PC2, PC3, and across our trunk line to switch 2. PC2, PC3 identifies it not as its IP address, and it deletes it, but switch 1 gets it in, sends it out all ports because we don't have any VLANs. PC7, 8, and 9 get that in there and says, nope, that's not my IP address. I'm going to delete it. Switch 3 gets it in, forwards it out all the ports. Gets it, and then it fails. So we can stop here. Now, reflection questions. If PC in VLAN 10 sends a broadcast message, which device receives it? Now, we're looking back here. we are looking at, I'm going to click on real time to get us back to a clean slate here. If a PC in VLAN 10 sends a broadcast, and that's what we did at the beginning of the lab here, sent out a broadcast, it only goes to VLAN 10. It doesn't go to PC2, doesn't go to PC3. It goes across the trunk. Broadcasts always go across the trunk, goes to switch 1. Then it forwards it to any VLAN 10 here, which is PC7, and it forwards it across the trunk. Gets down to switch 3, forwards it to any VLAN 10 here, so it forwards it to PC4 and any other trunk. Well, seeing as this is the only trunk coming in, we received it coming in there, we're not going to send it back out. Reflection question number 1. Answer is all devices that are on VLAN 10. Reflection question number 2. If a PC in VLAN 20 sends a broadcast message, which devices receive it? Same thing happens here. PC2 sends it out on VLAN 20, switch 2 gets it, forwards it to any other VLAN 20. We don't have any, and it forwards it to the switch 1 out the trunk connection. Switch 1 gets it, forwards it to any PCs in VLAN 20. PC8's there, so we'll forward it there, and we forward it across the trunk. Switch 3 gets it, sends it to VLAN 20, which is PC5, and any other trunks. And once again, we only have one trunk coming in, so we can't send it out the port we just got it in. And PC5 is the only device here that gets the broadcast. Our answer here is all devices that are on VLAN 20. Reflection question number 3. If a PC in VLAN 30 sends a broadcast message, which devices get that? Same thing as VLAN 10 and VLAN 20. Only devices on VLAN 30 will get it. Our answer here for question 3. All devices that are on VLAN 30. Reflection question number 4. What happens to a frame sent from PC in VLAN 10 to a PC in VLAN 30? If we send a PDU, a ping, an ICMP packet from PC1 to a PC in VLAN 30, what's going to happen? And that's what we did. We tried to ping PC1 to start with to PC6, and that failed. And this is, once again, remember, we had VLANs at this point in time. It failed because they weren't in the same VLANs. It was dropped. And so what happens to the frame there? Frame will be dropped because PCs are in different VLANs. In terms of ports, what are collision domains on the switch? A collision domain is where a collision happened. A switch does a couple things to stop collisions. First thing a switch does is only send out information, only send out packets that it knows the end device, that it's destined for that end device. If it's not for that end device, it doesn't send it out. It eliminates that traffic. The other thing it does is it uses full duplex. And what we mean by full duplex is traffic can travel in both directions. You can send and receive at the same time. Basically, there's 2 lanes of traffic here. Think about a highway. You're driving on one side of the highway, and that allows you to head the direction you're at. The other side of the highway, the second lane, is the direction coming towards you. That allows other people to pass you. You both can pass each other. You both can travel that road at the same time. But when that 2-lane road comes down to a 1-lane road, something has to happen. That's when we talk about half duplex. Traffic can travel in both directions, just not at the same time. When we come down from a 2-lane road to that single-lane road, 2 cars can't pass next to each other. One car has to wait while the other crosses. If neither car waits, what happens? Those cars are going to go and hit each other. You're going to have a collision. You're going to have an accident. Same thing with data. If both devices try to send data at the same time, nobody's going to get any data through. And you're going to have a collision. You're going to have some sort of accident. But when you come to that one-lane bridge, if one car waits while the other car crosses, once it's clear, that first car can then continue on in its direction. Yes, you will get to your destination successfully, but it's going to take you longer. It's going to have congestion. You have traffic waiting at different spots. And so what a switch does is each port on that switch is a separate collision domain. And that's our answer. Each port on a switch is a separate collision domain. Reflection question number 6. In terms of ports, what are the broadcast domains on the switch? Broadcast domains are where broadcasts go through. Think about when we sent a ping from PC1 to PC6. We had to do that ARP request. That first step on the ARP request is looking for that MAC address. It's a broadcast. That broadcast went down to switch 2. Switch 2 got it, and then it sent it out to all devices that were in that VLAN. And it also sent it out the trunk ports, because that trunk handles all VLANs worth of information. There was no other VLAN 10 on switch 2. All switch 2 did was forward that packet across the trunk to switch 1. Switch 1 got it in, forwarded it to all of the devices on VLAN 10 and the trunk port. So PC7 got it. Switch 1 sent it to switch 3, forwarded it to all the PCs, all the devices on VLAN 10, only PC4 got. And what's happening here is the broadcasts are only being sent to the same VLAN across all of these switches. Now, what are broadcast domains on the switch? They are divided by the VLANs on the switch. Every VLAN is a broadcast domain. Every VLAN is a broadcast domain. And once again, that broadcast domain is where the broadcasts are heard. PC1 sends out a broadcast. Only devices in VLAN 10 will hear that. That was Packet Tracer Lab 3.2.8, Investigate a VLAN Implementation. It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.